Sillars. I'm originally from Seattle. I lived in Seattle for 15 years. But for the last 3.5 years, I've been a digital nomad traveling around Europe with my family. The first year, I worked for AT&T for 10 years, helping make apps run faster. So I wrote a book on how to speed up mobile apps. Because if an app is slow, people get pissed off. And when people are pissed off, they stop using your app. And if people stop using your app, guess what? That's really bad for your business, right? Like, logically. The same thing goes for websites. So if your website is really slow, like think about like when you go to the mall, right? It's always really happy music, it's really bright lights, because if you're happy, you're more likely to pull out your wallet and spend more money. But when a website is slow, people are frustrated, right? And if you start off frustrated, guess what? You don't spend as much money. And when you're building a website that's trying to sell stuff, that's kind of important. So I've worked a lot on trying to speed up websites and apps. I do that as a freelancer now. I lead workshops on how to do that. And that sort of led me into images and video, because you think about what are the biggest things on a web page or in a native app. Like in terms of tonnage, images and video are really, really big files. That sort of got me into augmented reality and then into machine learning. So that's sort of my background and how I got into this. Way before I started getting into tech, I was a chemist and I did computational chemistry. So like, I sort of had that going on too. They mentioned like methamphetamines earlier, like as like the crack, and like if you work from home and you're a chemist, like they made a documentary in America called Breaking Bad about that. Like, if I work in tech, like that's a lot safer. It's not as illegal. So if you ever want to talk about any of that, I'm the only Doug Sillars on the internet. I'm easy to find. So like images. This is a random sampling of 10,000 images that I found on the web from April. And if you look, you can see that like for most websites, images make up over 50% of the stuff being downloaded. So if you can optimize that, if you can make those smaller, the web page is going to load faster. Right? We have JavaScript, we have CSS, but you know, these websites have a lot of images on them. So what can we do to speed up the images? And what I've found is it's the step of image processing, the getting the images ready to go on the web, where a lot of the issues happen. So if you're building a website, you've got to get some images. You can go out with your tripod and your camera, and you start taking pictures, or you open up Google Image Search, and you download a bunch of pictures. And the next step is you open them up into Photoshop, and you start doing some work, right? And then you put them up on the web. Right, that's sort of the process. But what I've found in all of my study of apps and websites is that this is the process that everyone hates. And we take a lot of shortcuts on this step. And when you take shortcuts, you end up screwing up the images and making them really, really large and making your website slow. All right. So as an example, one thing I see a lot of is people taking a screenshot of their computer and then putting that on their web page. This is not an ideal way to create an image. Like you get it all perfect in Photoshop, and then rather than saving it in Photoshop, you do the screen grab and then you post that. Like that's not optimal. And the reason it isn't optimal is you can actually do this. You can open up Chrome DevTools, and I went to a web page. And if you have a Mac, you'll recognize this format: screen_shot, year, month, day, time, right? .png. This is a website that they just took a screenshot and put it live on their webpage. Not ideal. So I went to a tool called the HTTP Archive, and what it does is it runs scans of 5 million web pages every month. And so I just did a regex and said, how many web pages have screenshot on them? And I found 426,000 screenshots live on the web. Most of them PNGs, a lot of JPEGs. Some are PHP images, I don't know. Right, whatever. Right, there's some GIFs, there's WebPs, there's JPEG, right? These are all things, JPEG without the E and with the E. All right, so like that's kind of crazy. It's 106,000 sites, which doesn't sound like that many, but then you think about it's out of 5 million sites, like that's 2% of the web. If 2% of the web is taking screenshots and putting them live on production, that's kind of a lot too, right? Like that's not necessarily ideal. So what's wrong with this idea? So I went and I grabbed 3,000 of these screenshots and I turned them into JPEGs, because PNGs generally you can get smaller if you go to JPEG in general. And then I optimized the quality of the image just a little bit, just to see if I could make them smaller. And I found that 86% of them got 50% smaller. 35% of them were 10% the original size. Right? If you could take 35% of your images and make them 10% the original size, guess what? Your web page is going to load a lot faster. So what are some of the shortcuts we can do for image prep? So like this is the image on the front page of my web page. What if I wanted to crop it? So I have this hosted up on a image hosting platform called Cloudinary. It's a cloud-based image hosting platform. They give you a URL, and then you can add parameters to that URL, and it'll optimize the image. So it's kind of low down here. I'm sorry for everybody way in the back, but it says C crop, so I'm cropping it, height 1000, width 1000, so I get that, right? The next parameters I have are optimizing the quality and optimizing the format. So it lowers the quality to where the human eye can't tell the difference. And it picks the optimal format. So if I'm using Chrome, it might serve a WebP. If it's in Safari, it might serve a JPEG 2000. It picks the right format of image that's going to be the smallest for that platform. All right, and we get a nice size image, and that's awesome until I get an image like this one, and I try to do a center crop, and like that sucks, right? So we haven't found the right process yet. This doesn't work yet. Luckily, Cloudinary had, so you can do a manual crop, but that's still, again, now we're, this is the part that people hate doing. So that's not your shortcut. They do have one of their tools uses some AI, and it looks for gravity auto. So it looks for the most important thing in the image, and thank goodness it thinks my face is one of the most important parts of the image, and like it worked, right? So it cropped it to 1000 by 1000, and it has my face in it. And it kind of centered the Swiss flag, so it kind of looks cool, right? That's a nice looking photo. So object detection is actually used in production on a lot of different websites. The biggest and most popular one you've probably heard of is Twitter. And so a couple of months ago, my son is a huge World War II buff, and we were in Poland, and he wanted to go see Hitler's bunker. And so this is a one-story building with 15 meters of reinforced concrete on top because, like, it was a bunker. And I posted this up on Twitter, and Twitter focused it on the door because that's the most interesting part of the bunker, right? Because that's just concrete. That's not really all that interesting. And so they have a whole post about how they do this object detection in their back end. It doesn't always work. So I had a friend who went to India, and he went to the Taj Mahal, and the seventh wonder of the world is at the top, and Twitter decided to focus on the people at the bottom, right? Like, these models aren't perfect, but we're getting there. So object detection with machine learning, we saw some previews to this in the last talk. Image AI, if you're interested, you can just Google them, and you'll find a bunch of Medium posts on how to implement this. They use the ResNet, the library of things. And so I took this picture of a town in England, and I said, tell me what you find. And I ran it through this, and it found a whole bunch of things. And that's really cool. Like, I didn't even notice there was a clock. Like, I knew there was a clock, but it didn't, it actually identified the clock. And it prints out all of this stuff with like crazy accuracy that I don't believe all these sig figs. Right, that's not legit. But it tells you it's 54% sure on the clock, X, Y of the box, right? So if you wanted to center it around the bus, it identified a bus. Pretty sure it's a bus, and it knows where it is, so you could crop the image around the bus now. It's really sure about some of these cars. It's not so sure about these two cars because they're not cars. Right? We're into machine learning. We're getting there. There's progress. It found a lot of cars, and it was also wrong on a few of them. It didn't find all the people, but it did find a bunch of people. It's still really cool. This is a really cool example. It's like a Medium article, you fire up a Jupyter notebook, and you get this going in 10 minutes. It's really kind of neat. So we can do object detection to crop around the face. If you ever use Google Street View, they blur out all the license plates on cars, right? So they can identify a license plate and they can blur it. They can do object removal. So this is in Munich. And they had enough photos of this square that they were able to remove all of this person except for his or her ankle and his or her boots. If you're interested, you can go there and see that. That's kind of cool. You could also do alt text creation, right? So you could take an image and figure out what's in there and create the alt text. So on a web page, the alt text is what people who can't see the image or the screen reader will tell them what is on the screen. And in this case, this image will tell you a person and 2 dogs. All right, so like these machine learning libraries, as you all know, are kind of like as smart as like a 2-year-old, right? A 2-year-old might not know that's a llama and might go, doggy, right? That's where we are. It's really sure that they're dogs. However, there's a different library out there. There's this really cool open source website. It's called llama.vision. And you can install it on your phone. It's a progressive web app, so you can have the thing on your phone. And when I fire it up and I just put it in my screen, it found the llama. And it's actually really cool. It's using TensorFlow as the back, TensorFlow.js, and I change it to iguana vision, right? It's up on my GitHub, so if you're interested, you can check that out. And it'll identify iguanas. This is live in production. Maybe you heard of his website called Facebook, right? So this is a picture I put up on around the 4th of July when I was back in the States. And Facebook is actually really good, so you never really see the alt text. You have to open up the source on the web page to actually see the alt text. But the alt text says, image may contain sky, cloud, ocean, outdoor, and nature. I like that image may contain, like as the qualifier. But in general, from what I've seen on the pages I've looked at, it's pretty good, right? Sky, cloud, ocean, outdoor, nature, like, yeah, we're pretty good there. So Facebook is now doing this in production. Like, this is brand new. This was like in the last 6 weeks they've added this. So that's kind of new and fun and exciting. But going back to like the llama, right? Like, what if you can't find any libraries that are trained to discover anything? What can you do? Well, you can create your own model. And I was doing this rope climbing course, and I was pulling out my smartphone, and of course, like, oops, I threw my finger on there, and I was like, well, what if I could like train a model to identify that and just remove it automatically? So here we go. I took a whole bunch of photos. That's my dog, Max. And I got my finger stuck in the photo, and I found a bunch of other photos on the internet, right? Right, where people, put their finger over the lens, right? And then I used Google Cloud Platform has an object detection model. And so with all these object detection models, you have to tell it where the objects are so it can train the model to identify it. And what's great about this model is you upload the images and you just go click, drag, right? So you don't have to figure out the X and Ys. You just click on the image and it knows where that finger was, and then you identify it as a finger. All right, so that's cool. So I've got all these images. I go and I trained the model, and I only used 43 images because I got tired really quickly, and it was a proof of concept, and I was doing all the training. But you can see I got pretty good precision. There were only 6 images in my test set, so it was right 5 out of 6 times on both precision and recall. Like, we're doing okay here. 1 out of 6 is a false positive, 1 out of 6 is a misprediction. But like this image, I send it up to the Google platform, so I have to deploy the model, and I'm going to show you an example of this soon. When you have one of these models deployed up on Google Cloud, they charge you like $2 an hour to keep it deployed, so you only have it up like when you actually get it up. And then you run some Python, like you base64 encode the image, you upload it, and it identifies things. So I did that, and it found the finger. It's 99% sure, and then those are the bounding boxes, right? And lo and behold, it found the finger. So then in the Python script that I have, I basically said, identify the box, identify if it's long, it's on the right side, the left side, top or bottom, and then, crop out the appropriate direction. Like I wouldn't crop it this way, I'd crop it that way. So that's really cool, like that's kind of exciting. I could now build like a thing where you could text your image, send an MMS off and it could crop your image for you. But I wanted to go a little further. Has anyone played with inpainting before? Anyone? All right, so OpenCV has this thing called inpainting where you create a mask, and then they have 2 models for inpainting. One is the Teleo model, and one is the NS. I call it the smeary and the blurry methods of inpainting. You'll see, because that's the smeary. It's not very good yet, right? You can see, and then that's the blurry. So what it's doing is it's finding the colors on the edge and then like baking it into the middle of the box. And you could imagine this could get better, like if it could identify that these are bushes and that was water, maybe it could do a better job of doing this in painting. But where we are today is this is what we've got in this Python library. It works really, really great on single color areas. So like up here in the sky where it's just blue, it did a bang on job, right? That actually looks pretty good. Not so much down at the bottom. Because the way it works is it has to be a rectangle, so I caught a lot of the buildings and that just kind of looks horrible. So I started playing around with in-painting, like could I trick it? So remove the outlier colors from the border. So I made grayscale, I ran some k-means and I found the most popular gray colors, how frequent they are, and then I removed them. I removed the outliers. And so it's better. And so when I do the in-painting now, like, it's not great, but it's better. So like this is a failure, right? As we all have, as we're learning machine learning. But as I was doing this, I started talking to this guy who works for a company. And his whole thing is they're selling sunglasses on the internet. Now the biggest thing about sunglasses is like whenever I go in, like I lose my sunglasses all the time. Anyone else? Right? I've got sunglasses in the bottom of the ocean, in the bottom of the Venetian Canal. I break them, I sit on them. Like my family's like 20 euros, Dad, that's it. But when I go to the store, my kids are like, no, Dad, that one doesn't work. Like I have to try on every pair of sunglasses and I have to go to multiple stores. When you're sunglasses on the internet, like you want to know what they look like on your face. You don't really care what they look like on the screen. You want to try them on. You want a little try on button there. So, like, how would you do that? Like, wouldn't it be great if you could take those and, like, put them on your face? Like, and that's what this company wants to do. So we're going to use object detection, we're going to do in-painting, and we're going to do that. Like, 10 years ago, they would have hired an intern. Here's 10,000 images, here's Photoshop, we'll see you in August, right? We'll see you next month. But I want to do this with, you know, with the AI and machine learning. So like I want to do this, but I want it to be smart, and so I want it to look good. And so this is what we're starting with. So what are we going to do? The first thing we're going to do is we're going to remove the background. Right? So there are a lot of tools that will do that. There's like remove.bg is a web page, it has an API that will do this for you. But you know, it still sucks because we still have the arms of the sunglasses right over our eyes, and that looks weird. You're not going to sell these sunglasses that way. That just looks weird. So, like, how do I remove the background? I use Cloudinary because I know Cloudinary and I use it. So in the uploader tool, I just use the background removal, and it gives me the image that has the background removed. All right, so there we are. I can then turn that image of my sunglasses to a PNG, because PNGs have a transparency, right? JPEGs aren't transparent, and then I can make them transparent and overlay them on my face. But again, we still have the arms of the sunglasses. We've got a problem there. So I'm going to train a model, download a whole bunch of sunglasses, upload them up onto Google, and it took a couple tries to figure this out, but I found the best way to do it was to have 3 regions per arm of the sunglasses. The temple, the arm, and then the tip. And you might say, why 3? Well, if I do in-painting here, I'm going to screw up the frame, right? Because the rectangle here gets the entire thing, but it's also going to screw up the frame, screw up the frame, screw up the frame. And sunglasses come in so many different lens shapes that I want to make sure I'm not getting the frame. And so what I found was if I did 3, I generally I screw up the frame here a little bit right there. I'd retrain the model a couple times because when you're drawing these boxes, after about the 15th one, you start to get a little lazy. And you really have to discipline yourself to make sure you're grabbing those bounding boxes well because, right, you know, just like most machine learning models, if you give it garbage, you're going to get garbage in, garbage out, right? So I made sure that was really good. So I start with this. I identify the arms of the sunglasses. If you find an odd number, it's not going to work. And so Ray-Bans really suck because they put the logo right there and it can't find that corner of the sunglasses. In this case, it only found like one of them, so it's not going to be able to remove the other arm. If it finds 6 regions, I'm gonna have a really good result. If I get 4 regions, it might be okay. Your mileage may vary, so you have to actually look at the ones where it finds 4 regions. If you find an odd number, you know it's gonna be a failure. That's gonna be a manual edit. When it finds those 4 regions, I white them out and then I smear in the color of the sunglasses, right? Because sunglasses, if I smear it, like sunglasses are dark here and light at the bottom, but the inpainting actually does a pretty good job of dealing with that. So that's kind of cool, it actually works. It sort of looks like my 3-year-old just ate a bag of crisps and then like was holding the lenses of my sunglasses, like they're a little smeary. But the great thing about this is I'm gonna make it really, really small on the web page, and so no one knows, right? There's that whole like, once you make it smaller, like it hides a bunch of your sins. All right, so let's put it all together. So I gotta pick, the second thing you have to worry about is when somebody's uploading a photo, you never know what the hell they're gonna upload onto the web page. Like you would assume it'd be just a picture of them. But in this case, it's a picture of me and like, you know, in Moscow, and it's not a picture of me, it's a picture of this whole scene. So I want to center on me. So, right, I do the gravity face, I center it on me, I make it 1500 pixels by 1500 pixels. I then download a photo of the sunglasses from the web page of the sunglasses company. I do the Python inpainting, I upload it to Cloudinary, I get a label, I make it transparent, and then I put it on my face. And I can do that all with URLs with Cloudinary. So like, once I have this image looking the way I want to, and this image of me looking the way I want to, they have an API that finds the eyes and will put something over the eyes and center it over the eyes. In this case, a pair of sunglasses. So, now we get to do a live demo. And so I've deployed this in, so what we can do is we can grab a pair of sunglasses from this web page. And so this is my Python script. And so what it basically does, I'm calling the Python, the glasses.py. This is the picture of me, and then the second picture is the picture of the sunglasses. I'm gonna change the pair of sunglasses to that new one. And so now it's downloading that pair of sunglasses, doing everything. It only found 4. We'll see what it looks like, right? Sometimes you win with 4, sometimes you don't. And that's the final image. So now we can take that URL, open it up on the web page, in the browser, and see what we get. It's not too bad. Like you can see a little bit of the arms, but it actually sort of looks like it might be just going behind my head, right? Like that might actually work. But we can change the sunglasses just because it's fun to do that. And so the way this web page works is if I just change that number, I get a new. Those are kind of the same though, it's just a different color. Those are kind of, that might not even work, but let's give it a shot because like those colors, I don't think it's gonna find them. But let's give it a shot because, you know, live demos. Let's go for it. And then I'll find a better pair of sunglasses for the next one while it's thinking through all of that. That doesn't even have the arms. What? All right, so this is just totally me like playing around with the web. Oh, all right, some aviators, that'll be fun. All right, but it only found 3, right? Because that last image, those sunglasses were a little weird. And so what does it look like? All right, great. So like that was a fail. Let's go on to the next one. Do you guys know about Control W to like remove the last parameter and it, like when you're typing stuff in the command line? It's so cool. I just learned about that recently. That's like my favorite thing ever. All right, I only found 4. Let's see what we got. That's not bad. I'll take it. They're probably too big. I think those are too, you know, like I think they should be small. They kind of look like clown sunglasses. But anyway, like as a first approximation, the goal was to try to build something that will do it, and it, for the most part, works. So, you know, in conclusion, There's a lot of stuff we can do with AI processing of images. This object detection stuff is still new. Like object detection and alt text is stuff that's actually coming out live in production, like recently in Twitter and Facebook, like cropping, blurring, object removal, alt text. Like this is all pretty cool stuff. Kind of the sky is the limit at this point. This is all still pretty new technology. I mentioned Cloudinary. They've got a media developer expert program, so if you like playing with images and video, they're really interested in trying to figure out different other ways to apply machine learning into those things. If you're interested, I have some flyers over in my bag. But with that, thank you so much for listening. I'd be happy to take any questions. Yes.
When I try sunglasses, the common problem is that they look good. When I try them, they're too small for my face.
Right.
You probably have a similar problem in such tools. You would have to somehow size the size of the head, the size of the glasses, and match.
So I think right now the API that I'm using right now is centering it around the eyes, but you're right, I probably also need to know the side of the head as well to make sure that it's accurate where they're actually fitting onto the side of the head. Because like that last pair I showed, they came out probably way too large and they kind of looked like a clown was wearing them. So you're right, that's one step that I don't have in the process.
But how do you think this would be? Did you think about it? Do you have some ideas how to?
I think if you had more facial, so right now I'm just using a simple API that says find the eyes and center it around there. I think I would need to have more information about locations of the face.
The problem here is more the size of the face, because if someone has a face like that and like that, you're gonna scale up and down glasses, which is not gonna come out as you showed.
Right.
Even if you find perfectly the match, it's not gonna be. You're not gonna get in the end.
Perfect. Right. Yeah. I haven't thought through all of those steps, but yes. There has to be something where there's a measurement of the size. Like you could actually probably through some other cues get dimensions of the face, and then you somewhere in a database have dimensions of the sunglasses as well to make all of that fit. But you know, for this, for what I'm doing right here, I'm just like centering it on the eyes for simplicity.
Any more question in the back or anybody? I have some basic questions to understand. So I think this kind of technology, a lot of e-commerce websites are also using, aren't they? Because they probably are trying to not only optimize the platform, but also people can try their stuff, just uploading picture and try on the website itself without doing some stuff.
You could totally imagine like if someone uploads a picture of their bed, you might want to put the pattern of a different sheets on the bed. Right, because you want to make sure that the coloring and the lighting and all of that. I mean, you could even do some augmented reality with that too, right? So if you can identify the thing, you could, you know, actually place things in the room to see if things work or if the colors are right. Yeah, I think there's definitely a big push for that. From an e-commerce perspective, I think there are a lot of other fun applications that, you know, you can just think about like Snapchat and Facebook filters, right, where they make your head look funny, right? They identify your face and stretch it out or make it skinnier or put a hat on your head or something like that. There's a lot of fun things you can do with it as well.
And you use TensorFlow.js?
In the back end of all of this stuff, there was some TensorFlow.js running, but yes.
But this is not the newer version, not the 2.0.
So
Is it out or? I don't
No,
know.
so it's just what's available today.
Yeah.
So you showed how fast it was to create these data sets with Google. Is there, can you also create other types of data sets?
So this is their object detection, like, they have a bunch of other, yes, there's lots of other types of data sets you can create with Google. This was strictly, they have an object detection like walkthrough on how to do it. But yes, they have a lot of different other things you can create as well. I just don't know them all.
Anybody else? Okay. If not, thank you very much.
Thank you so much.